Hi students, this is Dr. Joe Engley, and in this lecture we will continue to explore how humans use the Earth's water resources. In this lecture video, we will be looking at the causes of water shortages worldwide and at the consequences of water shortages on human population and the environment. Water shortages occur around the globe, and in recent years have become especially acute as cities, agriculture, and industry withdraw more and more water. Nowhere is this more problematic than in Cape Town, South Africa. In this image, we see a portion of the Waterkloof Dam close to empty in 2018, showing tree stumps and sand that is usually submerged by the water of the dam. This figure is a graph of the total water stored in the Western Cape's 6 largest dams from 30 June 2013 to 15 January 2018. The graph illustrates the declining water storage levels over the course of the Cape Town water crisis. This data is obtained from the Climate Systems Analysis Group. The reason for this is a drought in the Western Cape province of South Africa that began in 2015 and it resulting in a severe water shortage in the region, most notably affecting the city of Cape Town. With dam levels predicted to decline to critically low levels, the city announced plans for quote-unquote day zero, when the municipal water supply will largely be shut off, potentially making Cape Town the first major city in the world to run out of water. Through water-saving measures and water supply augmentation, by March 2018, the city had reduced its daily water consumption by more than half to around 500 million liters per day, resulting in the initial prediction of day zero in April 2018 being pushed back to 2019. The situation, however, remains severe, particularly if the run of record dry winters continues through 2018. Well, in this lecture, we will be learning about where and why water shortages occur, how we can increase water supplies, and methods that we can use to conserve water. As the world's climate continues to change, owing to increasing carbon dioxide levels in the atmosphere, changes in water distribution will lead to more droughts in populated areas which previously received larger amounts of rainfall. Perhaps more than any other environmental factor, water availability determines where we live and what we do. Some places, like Iceland, have small populations and abundant rainfall. Others, like Egypt, have large populations and limited water supplies. Almost all of Egypt's population lives adjacent to the Nile River. The Nile River is the longest river in the world. It flows northward from the lakes of Central Africa to the Mediterranean Sea. However, the Nile carries less water than many other rivers because it flows through the Sahara Desert in the north. 97% of Egypt's population lives in the river's valley. Technology has allowed exceptions to living in desert areas. Bahrain, which receives almost no rainfall, uses expensive, energy-intensive desalination systems to produce fresh water from the sea. Fast-growing cities in the U.S., such as Tampa, Florida, and San Diego, California, also depend on desalination for part of their water resources. In this figure, we see how quickly water can be resupplied to an area. Water supplies are resources that are replenished regularly, mainly surface water and shallow groundwater. Here we see the projected water distribution in 2025. The blue areas are the most water-rich regions in the world. The salmon pink areas are deserts. Water is a renewable resource, but renewal takes time. The rate at which we now use water makes it essential that we protect and conserve water supplies. Renewable water is most plentiful in the tropics where rainfall is heavy and large land masses. In this figure, we see the dramatic increase in water consumption since 1900 by region. The amount of water we use depends on a number of factors, especially how much agriculture a region has, how much meat we consume, how dry the climate is, and how much water is available to use. Direct household usage varies dramatically within a region or a state. On average, in the United States, we consume about 1,600 square meters per person per year. This high rate results largely from agricultural water use, as well as a warm climate and a rich diet. About 30% of that water footprint is from beef consumption. Mexicans, in contrast, consume about 750 cubic meters per year. In Northern Europe, where climates are cool and people consume modest amounts of meat, consumption ranges from about 100 to 700 cubic meters per year. Developing countries tend to use much less, often less than 50 cubic meters per person per year. Worldwide, agriculture consumes about 75% of water resources. Industry consumes about 20%, and domestic uses make up the remaining 5 or 6%. Water has always been the key to survival. Who has access to this precious resource and who doesn't has long been a source of tension and conflict. We use water for many purposes. Evaluating water consumption can be tricky, though, because much of it's exported in a variety of forms. In California, for example, about 15% of all water is consumed in producing alfalfa. Alfalfa hay feeds dairy cows and, to a lesser extent, beef cattle, whose milk, cheese, and meat are exported all over the United States and overseas. Rapid expansion of alfalfa irrigation actually helps explain why Wisconsin and Vermont are struggling to compete in the national dairy market. California also exports alfalfa hay directly to China, Japan, and elsewhere. These exports are often described as, quote, virtual water, unquote, exports. Similarly, California's almond crop consumes about 10% of California's water. Almond growth has exploded in recent years. From about 60,000 tons produced in 1960, the industry expanded 30-fold to 1.8 million tons per year in 2013. That represents 99% of all U.S. almonds and 80% of the world's almond supply. To keep trees alive year-round, as well as to produce the nuts, requires nearly 4 liters of water. That's more than 1 gallon for every single nut. On a per kilogram basis, this amounts to 16,000 liters per kilogram, or 1,900 gallons per pound of almonds. This is about what is needed to produce a pound of beef. Producing a lettuce takes about 800 liters per kilogram, or 100 gallons per pound. By some estimates, the water content in exported alfalfa amounts to 380 million cubic meters, or 100 billion gallons per year, enough to supply about 1 million families with drinking water for an entire year. Conservation proponents argue that reducing water exports could dramatically reduce the water crisis in the American West. Our water footprint depends a great deal on what we eat. Raising a kilogram of beef in a concentrated feeding operation, for example, takes about 15,000 liters of water because cattle are fed corn, which we grow in water-intensive irrigation systems. The result is that the average hamburger takes 2,400 liters or 630 gallons to produce. Raising goats is a much more water-efficient way to produce meat because goats eat a more varied diet and they metabolize their food more efficiently than cattle. Rice cultivation, which generally occurs in wet paddies, takes about 3 times as much water as raising potatoes or wheat. If rice is grown in a rainy region, providing this water is rarely a major problem, but some countries, including the United States, depend on abundant irrigation for rice growing. For some foods, the greatest water use isn't in growing the crop, but in preparing it for consumption. For instance, chocolate is highly processed before we eat it. Industry uses include energy production, but industrial and domestic uses tend to be far lower than agricultural uses. Industrial uses represent about one-fifth of all water withdrawals worldwide. Some European countries use 70% of water for industry. Less industrialized countries use as little as 5%. Cooling water for power plants is by far the largest single industrial use of water, typically accounting for 50 to 75% of industrial withdrawal. If treated properly, much of the cooling water can be recycled for other uses. Biofuel production, or ethanol from corn, also demands extreme amounts of water. It takes 4 to 7 liters of water to produce 1 liter of ethanol, depending on how much irrigation was required to produce the feedstock. Since 2008, another dominant industrial use of water is hydraulic fracturing, or fracking, for natural gas and oil production. As the name suggests, water is pumped under pressure into oil and gas wells to help fracture geologic formations and release hydrocarbons locked in the rocks. Fracking one well uses 4 to 6 million gallons of water. Sometimes wells are fracked more than once in order to release additional gas. Most of this water returns to the surface, but it is too contaminated to be reused without a great deal of treatment. Contaminants include carcinogenic hydrocarbons as well as detergents that aid in the fracking process, and salts and radioactive particles from deep underground. In areas of intensive oil and gas development, as in western North Dakota, northern Texas, and Oklahoma, water resources can be severely stressed by fracking demands. Drought-stressed California is also using millions of cubic meters of water for fracking. Domestic water use for drinking, washing, and cooking accounts for only about 6% of world water use. Amounts of use vary with wealth, however. The United Nations reports that people in developed countries consume on average about 10 times more water per day than those in developing nations. Poorer countries often can't afford the infrastructure to obtain and deliver water to citizens. When a city cannot pipe safe public water to neighborhoods, residents have to buy high-priced water delivered by truck. The cost of this water can help keep families in poverty, but they have little choice. Providing clean water to poor populations is one of the primary aims of international development organizations. Clean drinking water and basic sanitation are necessary to prevent communicable diseases and to maintain a healthy life. The United Nations estimates that at least a billion people lack access to safe drinking water and 2.5 billion don't have adequate sanitation. As populations grow, more people move into cities, and agriculture and industry compete for increasingly scarce water supplies. Water shortages are expected to become even worse. Rural people often have less access to good water than do city dwellers. Water-related diseases such as diarrhea are common in areas with poor sanitation. Every year, about 1.6 million people, 90% of them children under 5 years old, die from diseases. More children die from diarrhea than malaria, measles, and HIV/AIDS combined.